Good morning, students. Welcome to your physics class. I hope you are doing good and are in good health. So let's start with our class.
Students, in our previous videos, we have seen the concept of thrust and pressure in detail. We have also learned the applications of the concept of pressure. Okay. So in our today's class, we are going to start with the concept of buoyancy. Okay. What is buoyancy? What is buoyant force? Why objects float or sink when placed on the surface of water? For that, we will see the laws of flotation also. Okay, so let's start with our class. Say you are holding a slightly heavy object in your hand. Now, if you are trying to hold that object within a container full of water, you will notice that it feels lighter. It doesn't feel heavier at all. What happens when you put an empty glass into a container of water? Of course, the glass fills up with the water. So, you are holding the glass of water inside the water which is in the container, and now you try to take out the glass outside the water. What do you notice? Yes, the glass feels heavier when it is outside the fluid, and the same glass full of water felt light when it was placed inside the fluid. And that brings us the concept of buoyancy. Now, what happens when an object is placed inside the fluid? The fluid pressure will increase with them. And now, because the pressure increases as we go deeper, the force exerted upward due to the pressure will be more than the pressure exerted downward due to the weight of the object. So, the force exerted on the bottom of the object due to the pressure will be more than the force exerted on the top. So, this net upward force exerted on the object submerged in the fluid is called the buoyant force. Now, you can test this with the tightly closed plastic bottle and a container of water. If you drop the bottle on the fluid, you will see that it will float. That's because the fluid is applying an upward force on the bottle. Now hold the bottle and push it inside the fluid. You will notice that the bottle is also exerting an upward force on your hand. If you will leave the bottle, you will see that the bottle will come up on the surface on its own. I think that you can guess now why. Now push the bottle deeper inside the fluid. You will feel more force against your hand, and when you will release the bottle, it will rush back to the surface. It will come up faster than it came in the previous case. The upward force increases as it pushed deeper into the fluid. That's because the pressure also increases as we go deeper into the fluid. This upward force exerted by the water on the bottle is known as upthrust or the buoyant force. Now, if we drop a piece of balsa wood and a metal drawing pin of the same mass into a container filled with water, what do you think will happen? Will both of them float? Will the both of them sink? Or one stays afloat and one sinks? By intuition, we can say that wooden block will float and the metal pin will sink. But if they are of the same mass, why does this happen? Shouldn't both float because of the buoyant force? This happens because of the difference in their densities. But what is density? Look at these two parking lots of the same size. One has 3 cars and the other has many cars. Which one is more dense? This one, correct? Yes. Now look at these two forests. Which one is more dense with trees? Clearly, it's this one. So, in the same amount of space, if there are more things, we say that they are denser. Density is just the measure of how compact the mass in a substance or object is. If we draw, if we have to go by its scientific definition, we would say that it is mass per unit volume. In short, it tells us how mass exists in the given volume. The unit of density is kilogram per meter cube. Mass is in kilograms and the volume in meter cube. Coming back to our example, why did the wooden block float and the pin sink? The wood floated on the water because the density of the wood is lesser than the density of water. Hence, the upthrust of the water on the wood is greater than the weight of the wood. Hence, it floated. But the density of a metal pin is more than the density of water. Though it looks tiny, there is more mass per unit volume within it as compared to the water. Hence, the upthrust of the water on the pin is less than the weight of the pin. So, what can we conclude? If the densities if the density of the object is lesser than the density of liquid, then it will float. And if the density of an object is more than the density of liquid, it will sink. Right?